In this video, we're going to look at some quick worked examples of calculating powers and roots. Let's start off with 3 to the power of 2, or 3 squared. This tells me that I'm going to be multiplying the number 3 and I'm going to have 2 of them. So we end up with 3 times by 3. A common misconception is that we do 2 times by 3. 3 squared is not 6. It's 3 times by 3, which gives us 9. If you wanted a visual representation, we could think of a square now with side length of 3 centimeters. So if we had this square just here, 3 multiplied by 3, this would give us the area and this would give us 9. So 3 squared is 9. If we had 3 to the power of 3, this is telling me now I need to take the number 3 and I need 3 of them. 3 times by 3 times by 3. We already know that 3 squared is 9. We simply multiply it by 3 again, and that gives me 27. Again, if you wanted a visual representation, you could turn this into a cube, and you could have a 3-dimensional shape. 3 to the power of 4 is going to be 3 multiplied by the 3, multiplied by the 3, multiplied by another 3. So our base number is 3. The number of them that we require is 4, so all we need to do is multiply this answer by 3, and that's going to give us 81. So if we took now 5 to the power of 2, or 5 squared, this is 5 times by 5, which gives us 25. It's not 10. 5 squared is not equal to 10. This again is a common misconception. So if I wanted 5 to the power of 3, I'd have 5 times by 5 times by 5, which is going to give us now 5 lots of 25, which is 125. And I could keep going. 5 to the power of 4, you're not likely to be asked to do this, but again, we would just have the 5s and we would have 4 of them, and that would give us now 625. So 5 to the power of 4 is 625. So that's calculating powers. Let's look at 2. 2 to the power of 1 is going to give us 2. 2 to the power of 2 is going to give us now 2 times by 2, which is 4. 2 to the power of 3. This is another one that seems to cause problems. 2 times by 2 is going to give me 4. Multiplying it by 2 again will give me 8, not 6. It's not 3 times by 2. 2 to the power of 4, we're going to multiply this by 2 again, and we're going to end up now with 16. This gives us the powers of 2, and if we kept going, we would have 32, 64, 128, 256, and so on and so forth. So this now is calculating a power. Sometimes we will be asked to find a root. Often it's the square root. Now, if we were asked to find the square root of 9, if we consider what we've done here, 3 times by 3 is 9, so the square root of 9 is going to be equal to 3. Technically, it's plus or minus 3, but in this particular video, at the level we're working at, to simply state 3 would be acceptable. The reason it's plus or minus 3 is that we could have minus 3 multiplied by minus 3, which would give us positive 9. So we can say now that if 3 squared is equal to 9, the square root of 9 is going to be equal to 3. We can see the inverse relationship. So 1 now sends it one way, and now we do the inverse to send it back. So if we now looked at the cube root, so the cube root, and we would have now the notation with the same as the square root, but with a little 3. This is saying now, what is the cube root of 27? So we're looking for 3 numbers that multiply the same number to give 27, and that's going to be 3. So the cube root of 27 is 3. We know that 3 cubed is 27. So the cube root of 27 is going to be 3. It's not 3 cubed. So sometimes students write here the cube root of 27 is 3 cubed. It's just 3. If we look now at the cube root of 64, so we're looking at the cube root of 64, we need 3 of the same number multiplied now to give us 64. If you're unsure, you can just work up 1 times 1 times 1 is going to be 1. We can see that 2 times 2 times 2 is going to be 8. 3 times 3 times 3 is going to be 27. So all of these are too small. 4 times by 4 is 16. Times by 4 again is going to give me 64. So the cube root of 64 is 4, because we know that 4 cubed is going to give us 64. These are inverses. So if we were asked now to find the square root of 100, this is saying to me now which two numbers, the same numbers, multiply together give us 100. The square root of 100 is technically plus or minus 10. I'm going to write the positive value of 10 as 10 squared is equal to 100. So we're doing some basic calculations now with powers and roots. These are about as tough as the ones that you'll be given, but hopefully you can now understand the relationship between the inverse functions.